what we're going to do right now, we're going to take and do this 300 radius on both sides of this, and they're offset 73 thousandths. And so I'll show you a little technique that I use to get my boring bar set up at that radius. There's different ways you can do it, but this works out pretty simple. And so first thing I do is I just took a piece of coal roll. This was a nice one I had laying on the shelf that was actually surface ground, so that makes it nicer, nice flat surface. What I'll do, I need to have a reference. So if I edge find this, there we go. I can set my digital 0, and because this diameter is 200 thousandths diameter right here, I'll wind half of that. It'll be 100. And then I'll reset the digital to 0. So what that does is put the center line of my spindle on this surface right here. At this point, I can put the boring head in. And I have a left-hand boring head so that I can spin in a clockwise direction. This boring head, it's screwed on up here, and one of the things, you can use a right-hand bar, but what will happen, you take a chance on that coming loose, which I've never had it done yet. But with the left-hand boring bar, it will just be a little safer. And let's see. So now what you do, we know that this is 0. We want a 300 radius. What we'll do is we'll move in 300 thousandths. So we moved in this direction 300 thousandths. Okay. So what we'll do now is we'll pull this boring bar, and we're just going to rough set it right now. Actually, let's start this all over. Yeah, so what I did, I moved this 300 thousandths over. We're going to bring the cutting tool down, and what I'm going to do is I'm going to just wind it close, eyeball it. And then I got a piece of Starrett shim stock over here. It's 20 thousandths. I'm just going to be moving that in and out as I go in, just to know that I'm within 20 thousandths. Right there feels really good. Now I'm just going to ink this up a little bit. That will give me some contrast. I'm going to move my dial in. Let's see, there's 10, about 18. Okay, I'm really close right now. And so what I did is I just went back and forward from the high point there, just to see if I'm going to scribe on that line. I can move it over a little bit, and yeah, you can see that I'm just scribing on that, just touching, and that's pivoting that and finding the high spot. And for what we're doing, it's clearance. I'll be plenty close enough. If you want to get this more accurate, you can hold a round piece in here that's close to size, a little bit bigger, indicate on it, and you can actually bore it, and then you can actually mic it until you got 600 thousandths on there, and then you have a 300 radius set. What I have done off camera, I got this boring bar. I got it set in this V block, and because this diameter right here is thicker than that, I had to use this extra little V that I made that you probably have seen in a previous video. So I'm using it here. It holds everything up. That way I'm not interfering. When I'm holding onto this diameter, I'm not interfering with this diameter hitting anywhere. And so I have it indicated on the granite. I got that flat indicated in good. And so now I can set the V block. Okay, it doesn't want to bridge that gap. I thought it would bridge that gap good, so I'm going to pull it off this way a little bit. I always like to work in the center of my vise as much as possible. That's why if this was a little bit wider, I could bridge that gap. I like the Kurt vices and that style. The thing I don't like is the gap in the center. So what I have to do now, I got my boring bar set. I'm going to take it out. And the next thing I can do is I got to indicate this boring bar, not the head, because it's on a little bit off, a few thou. And so what I want to do is I want to pick up on the carbide shank. What I'm doing, I'm trying to spin this to get that where it's real close to pivoting on the center line of the spindle, and then I can just come over and eyeball it to the center that I can still see on there, and that's going to get me close. I'll just set my digital 0 at this point. Okay, I'm using the 10th indicator. I like just using that on everything. I hardly ever use my 5/10 indicator anymore, but you can at least not that side, but this side you can probably see it's pretty darn good. It's less than a few tenths out. We'll move back to 0 there, lock that down, and we'll just snug this one down. And what we got to do is we got to move off 73. I'm going to go probably about 100 to start with, just to see what it looks like. Yeah, 73. That was going the wrong way. I got to go less than the 73 because I'm actually cutting this side. And that's one of the things when you're cutting on this, everything is a little bit backward. So this is why it's good to double check what you're doing before you get there. Because I'm actually moving the table this way, means I'm cutting this side. And I went further than 73, and I could tell something looked wrong. But I got it figured out. I backed it off now. We're about 27 in, not touching there. We've got plenty of clearance, and so you can see we got clearance, and I don't think we're going to be even touching at that point. So there's about 48. And what I'm going to do is I'm going to set my speed while I'm spinning above, just so I'm not hitting anything. And what I'll do is I'll just gently ease it in. And we're just hitting some of the high spots. Other thing I'm going to do is I'm going to set my stop. set my stop just so I don't come down and hit the block over here. Yeah, so there's 48. Take off about 7. Bring it to about a 55 or so. Here's 65. About a 10,000ths cut. The nice thing about this is it also lets me test the solder joint because there's a lot of pressure on there now. And the solder joint is holding up real nice. And now we'll go 73. And I'll use the power feed at a real slow setting, just try to get a nice finish on there. What I'm going to do is I'm going to turn it off there, pull it back up. I'm going to take a spring cut, go in the same direction. Okay, so what we'll do now is we'll go 73 the other way, work into it just like we did here. And do a spring pass, and then we'll check our sizes. Grab the calculator. What we should have is 600 minus our offsets of 73 on both sides. So 146. So 0.6 minus 146, 454. And here we can fine tune it if it's a little under. We got a little more clearance if it's over, and then I can just wind the head. Okay, that's what I was shooting for was 454, and I actually went 73 and 2/10 on both sides, and it looks like we're measuring 452 and a half. I don't know if you can see that in the camera, Cat.
Kind of. There's just a little glare on it.
Anyways, so we're just about a thou or so under. And it's clearance, so that's better to be a little under than over. But that was just a quick, simple way of setting up that boring head and getting fairly accurate on your cut like that. So now, when we come back, I'm going to set this all up so that we can cut this shape in over here in the flat. And what we'll do then is drill and ream that hole and get that sized up just right. And then we'll have to flip it up, and then we'll have to put the 1032 cap here, and then clearance over here. Actually, before we do that, I got to put some 45s on there. Almost forgot about that. when you're using the boring heads, these T-handles, I brought my set home from a full-time job. They actually work good, especially for the adjustment over here. But they work really good on these boring heads. Okay, what I do is I got me a little carbide. It's actually 82 degree included angle countersink. It's 41 degrees. But all we're doing is breaking these edges to make it look nice. And so when I put this in here, I'm going to have to run it in reverse. So this is the part where you got to be careful because you're running in reverse. And I'm just touching right there. Robin's calling for 63. We'll see how well this works. I don't know if I'll go that deep. We'll try it at about 20 at a shot. So there'd be 20. Went really nice. 20 more. And there'd be 60. Oh yeah, cut real nice. So now I'll have to move 73 in the other direction. There we go. Oh. Here's where you gotta be careful. I went the wrong direction, and this I have to cut going the opposite direction because it's cutting left-handed. And there we have it. We got our nice chamfers on top. Everything's looking real good at this point. We got our radiuses, our offset radiuses. We got that in, and we'll come back. When we come back, we'll have a different setup on here, and we'll start doing some of the other work. Okay, what we're going to do at this point, we're going to just clean this surface up so it's running nice and true with the bar. I also had to pull the bar out a little bit so that I'll be able to edge fine in this section right over here to get the center of the bar. Before I wouldn't have had enough room. That would have been hard to sweep with an indicator as well. We use the smaller end mill to generate less pressure. Barely took the 1 to 2 thousandths off, and the reason I'm doing that, there's your blank passes on there, is because I want to establish a good surface because I'll be edge finding that surface as well. Well, it's a good thing Robin sent me 3 of these heads, because I messed up the one I got in a hurry, and I paying more attention to doing the YouTube video over here than paying attention to the blueprint. But the center line of the head is right here, but the center line of that hole was 47 thousandths off center, and on the first one I put it right on center. And it really was kind of a good thing, because when I pulled the old head off, the joint wasn't as good as what I wanted it to be anyhow. So I made sure on this other joint it came out beautiful. The solder came right up, a nice seam all the way around. I used that marker system on there that I mentioned, and it worked perfect. I could see where the part would drop right down, and so that would tell me that it seated in good. And you can even tell it when machining it, because I already machined it, got it as far as what we had in here, and the head's setting on a lot straighter and everything else. So this is a time when one of those mistakes actually worked out to my advantage. Because this is off center, I'm not going to use a center drill off on the crown. I'm going to use the 3/16 carbide end mill that's center cutting, and I'm just going to put a little spot face pocket on there, and then I'll go with the center drill in there. And the reason I'm doing that is because you have this crown right here, and if you don't spot face that and you put your cutting tools like drill bits, different things in there, and especially being off center on that crown, they'll have a tendency to walk and move around on you, and this way it will assure the alignment is there. So I already have it positioned in 2 places, and I got to go back 47 thousandths this way. Yeah, so.
And this number's right?
Yeah, so the 395 and the 47 thousandths, and they're both correct, and I'll have to just start double checking from here. Can you zoom up on that?
Not a lot.
Okay. I don't know if you can see it in the camera.
I can see it, but I can't zoom in closer than I am.
Okay. Yeah, you can see we're hitting on this side, and I'll bring the spot face all the way down till it just touches on the lower side over here. There, now we just barely have a lip down there, so we're good. We got a 3/16 spot face, and that'll keep my tools from deflecting. Now we'll just put a little almost just the very tip of this center drill. That's about all I went in there, just to give a little point to center the drill. That's a 180 drill. And that's just kind of really where I wanted it. Because now I'm going to take a 3/16 reamer, which is about a thou bigger, and go through there. That one was about a thou small. And there you have it. Real nice fit. So what we're going to do now is we're going to side mill this flat right here where the button head screw comes down. Are you seeing it? Okay. And so we're going to mill that, and then there's a little bit of an undercut that's over here, and that's to make sure there's no interference when the button head screw comes down on the part there. So we're going to put that in now. Looks like I need to come up to a 321 thousandths by the time I add the flat and half the end mill. I'll probably go a little less than that because end mills sometimes cut a little bit over, but what I'm going to do is I'm going to just chop into the part first. We're going to flip this block 90 degrees, and then we can come in and we can put our tap toe in. And now we're going to be doing the tap hole and the clearance hole for the 1032 button head. We've got everything located. Now we're going to tap at 1032. Okay, we have it set up now so that it just barely touch. It's lining up right on the center line of the hole. I actually measured that all out, so it should be good. And now we're just going to ease that down in until we cut through the hole. That wheel is 46 thousandths. That's what Rob was calling for, the 45 thousandth slot. I don't have any small end mills, and getting one that small and that material that's kind of hard like that anyhow, which you saw with that tap toe, would be difficult. So this is the direction that I'll be going. It's an aluminum oxide cutoff wheel. It's a non-reinforced one. You've seen some of our other videos where you use them. They cut really nice. So once we get this down and get down through to the hole, and then from there it's just deburring and the bar's done, and the only thing that's left will be making little cutters that go in there. There, we're all the way through, and just as we're breaking through, it looks like it was wanting to pinch in just a little bit. That's why I had to take it nice and easy and give it time to clear some of that pinch factor out. Because if I would have got too aggressive and went down on that, it would have pinched into the wheel. Those things are very brittle. It could have been pretty ugly at that point. So now we got to deburr it, and then what we got to do is make the screw the right length, and we'll be ready to go. In fact, what I'm going to do, while I got the cutoff on here, I'm going to stick the screw in there, and then I'll just use the cutoff wheel and cut it close on the back side. I think that'll hold tight enough for cutting that. There we go. What we'll do is we'll get it all deburred and cleaned up, and then we'll show you the final product. Well, the boring bar is a good build. It's finished. The only thing that's left to do now is to take these carbide pins and grind Keith a few cutters up out of that. And that will be in a separate video. But it turned out really nice. I'm real happy with how it turned out. And I am kind of glad that I messed that first one up, because you can look right down here and you can see that we got a real nice braze coming all the way around, all the way up over that silver solder. So it actually worked out for the best. And yeah, hopefully this works out real well for Keith. Thanks for watching. We'll see you next time.